Okay, so just to repeat, the main point that we're dealing with in NServiceBus, we're talking about a different kind of abstraction for communication, non-synchronous. You will not be getting into situations where you're saying, I'm blocked waiting for a response from somebody else. The main place to start looking for publish subscribe is between different business domains, things that at a business level can largely operate independently of each other. So the scenario that we said, sales publishing an event saying, I've accepted an order. Really, I have, and I'm not going to change my mind. At which point in time, NServiceBus can transmit that event to everybody who said that they're subscribed. For example, billing. Billing says, I'm interested when orders are accepted because then I've got to bill the customer for what they bought. And it ultimately does its internal billing business logic, whether it's against its own database or integration with a third party, or a legacy application, does what it needs to do, and it may in turn publish its own event saying, customer billed for order. And the guys over here in shipping say, well, I heard that an order was accepted, but I'm not going to ship it yet. I have to make sure that customer paid for it. And only when the second event arrives from billing that says, oh, customer was billed for the same order, should I actually go about my business of doing the shipping. So when looking originally for where can I start using NServiceBus, start by saying, how can I divide up my business domain? How can I identify these kinds of events such that the NServiceBus publish subscribe model will make sense? So that if something is in the sales database but isn't yet in the billing database, that's okay. It can be sitting there waiting in a queue for it to be processed. Not everything needs to be 100% up to the millisecond consistent. And part of our goal is to find those places where the business is willing to relax those constraints. And it may be important to do it quickly, but quickly does not mean synchronously. So by and large, when everything's up and running, everything will run fast. Believe me, NServiceBus is very efficient. Can do thousands and thousands of messages a second. But in the case where something goes down, something crashes, something bad happens, the other areas can continue to operate in parallel until the machine comes back up. That's the first place to look at using publish subscribe. From there, you can start looking to other places. Say, oh, okay, well, I may have in my sales area, when I get an event that says, okay, the customer's been billed, I may want to get some kind of feedback to the actual salesperson that closed the deal. So I may end up doing some publish subscribe between a server in my sales service and a bunch of clients. You can also do publish subscribe there, but again, you'll be looking at a single publisher. One logical thing that says, I'm responsible for this event. I may be scaled out behind a load balancer. I may be clustered for high availability, but logically, I am one and only one from the perspective of all the clients around me. So once we've done that, once we've gotten our assumptions right, then using NServiceBus is actually fairly trivial. John, what did you leave over on my machine? What is that over there? So this is the publish subscribe sample that you get with NServiceBus. So after downloading NServiceBus, the big green button that we saw before, and you'll put it on, say, D somewhere, D NServiceBus. So under the samples directory, you'll see publish subscribe, and then this will open up for you. In here we have a definition of messages, And our publisher will occasionally publish those messages. So I want to show you really quick what that looks like. So I'm clicking F5. This is subscriber number 2. It'll be on your left. This is subscriber number 1. It will be on your right. This is the publisher. It'll be on the top. What's going to happen is that the publisher will be publishing events. Every time I click the Enter button, the publisher will publish an event. One of the things that you'll notice is that events may not go to both subscribers. And I'll tell you why in just a second. So here's one enter. Only appeared over here, right? So we actually had only one subscriber for that event. And now I'm going to publish another event. And both subscribers received it. That may seem counterintuitive to you. Either it goes to everybody or it goes to just one person. How is it possible that this is publish-subscribe? How is it that my publisher can cause this to happen? So before answering that question, but I want it to be fresh in your minds, we're going to talk about some other scenarios that I mentioned, the failure scenarios, where one of our subscribers goes down. So here we go. We're going to be taking down subscriber number 2, and he's dead. And now our publisher is going to be publishing a bunch more of events. And we're going to go back to our subscriber number 2, bring it back up, and we're going to see that all the messages that were published before have now arrived. They haven't been lost. Here, all of them arrived and are processed. Not like the publisher would care, or it would make any difference to them either way, that somewhere in the middle of all of this, a subscriber crashed and restarted. Oh, big deal. Unfortunately, with most of your WCF service-based communications, if this were to happen in the middle of any kind of communication, in the best case, those calls would be lost. In the worst case, it would dry up the resources on your server side, causing it to crash as well. But luckily, we don't do that with NServiceBus. So far, so good. The next thing that we're going to do is we're going to talk about that issue of apparently publish, subscribe, but the fact that sometimes, as a subscriber, I get both messages, and sometimes as a subscriber, I get just one. The thing is that events, as we said before, mean something. What's interesting about an event is the statement of fact. It's the business logic that's going to be running. It's not the fact that, oh, cool, we're transmitting bytes from one machine to another. That's a solved problem. Publish subscribe is all about semantics. And one of the things that we can do is to enrich semantics. So we can start with a definition of an event that says, this is a semantic something. And it stands on its own. Okay? This is an order accepted, the trade submitted event. And then in version 2 of a system, somebody comes along and says, yeah, but we've got this special new kind of trade that when it's submitted, well, yes, it's submitted, but it means something else. There are some subscribers that will particularly care about this new kind of trade, while there are other subscribers that don't give a damn and want to treat everything exactly the same way. As a publisher, you'll know which trade you're dealing with, whether you've received trade of type 1 or trade of type 2, in which case you will publish the right event, either You'll publish this, or you'll publish that. See some puzzled faces saying, how would you publish an interface? What does that even mean? We'll get to that. Just to make this equivalent, let's make this an interface as well. Okay? Which is even great, because I can get rid of all this crap. Okay, so we've got two interfaces that look exactly the same. But the semantic meaning is different. This is representing a trait of type 1, and that is representing a trait of type 2. Some subscribers will say, you know, I don't really care which type of trade you're doing. I'm going to process it exactly the same way. I'm going to code against the more generic message. Whereas there may be some other subscribers that say, no, actually, I'm really interested in that specific message type too. What we'd like to have happen is for the routing to just work. If I publish the second type of event, all the subscribers to the first type of event should receive it too, right? Because event message is a iEvent. The inheritance here is telling us what the semantic meaning is, which reflects on the routing decisions of NServiceBus, which tells me down here, subscriber number 1 says, you look like you're interested in the specific trade of type 2. And therefore, you should only be notified when specific type 2 trades arrive. Whereas other subscribers down here says, no, I really don't care. I want to be notified about all trades. And on the publisher side, I'll decide, well, what am I publishing? Am I going to create this type of message? Or am I going to create this type of message? In other words, as a publisher, I know which type of trade I have just accepted. So I'll publish the specific type of event that reflects that semantic. Ultimately, it's fairly easy. Just one line of code says, once you know what you want to publish, just tell the bus to publish it. And based on the semantics that you have baked into your schema, NServiceBus will say, oh, that subscriber's interested in type 2. And that one's interested in type 1. In this case, what the publisher is doing, it's alternating. It's saying, I'm going to publish type 1, then type 2, then type 1, then type 2, then type 1, then type 2. And that's the behavior that we see. The generic subscriber receives both of these messages and processes them both. The specific subscriber only receives the type 2 events. So some events it just doesn't know about, don't arrive. So when we run this, that's exactly what we see happening. As a publisher, I publish one type of message. I start saying, this is a type 2 trade. So only subscribers that says, I want to know specifically about that thing will be notified about it. Or the publisher can say, you know, this is a generic one. Or sorry, it's exactly the opposite. This is a type 1 and this is a type 2. So if I'm only interested in type 2 events, don't tell me about type 1 events. I don't want to hear about it. Whereas over here, both type 1 and type 2 events arrive. This gives you a great deal of flexibility when versioning your publisher. When in version 3 of your system, your business analysts come along and say, we had this great idea. You just wouldn't believe it. We're going to have a new type of trade, okay? So let's start say, okay, we don't have this. We're going to have a third type of trade, type 3, trade accepted, which inherits from them both. In other words, a type 3 trade is both a type 1 trade and a type 2 trade, and it has a special string property that says something. But we don't want to change the rest of the system. All the subscribers that are interested in type 1 messages should keep getting type 1 messages. Everybody who's interested in type 2 should continue getting type 2. When we publish type 3, everybody should hear about it without them knowing about type 3 trades. It's a new thing that we added to our system that is semantically equivalent to the previous 2 types of events. And the nice thing about using interfaces is that you can do as much multiple inheritance as your heart desires. If you were to use classes, well, you'd be kind of stuck. You can't semantically represent that one class is 2 other classes. C# won't let you do that. The reason that multiple inheritance works and makes sense is because we're dealing with data transfer objects. We're dealing with things that do not have behavior. Events are things that have already happened in the past. They just tell you what happened, nothing more. And in that case, it's very useful to have this capability of enriching your message schema from one version to the next, to the next, to the next, representing what thing is another thing. And all the publish subscribe just works. All the routing continues to work because NServiceBus is made aware of your semantics. So the strength in NServiceBus when doing publish subscribe or in handling versioning issues is not so much let's give you your own customizable XML serialization callback events and you figure it out. The issue with standard XML serialization when using classes, if you can only inherit from one class, you have to compose another class, right? I'll inherit from A and I'll have a property of type B. And then I'll require what's known as content-based routing. I'll need my service bus, or my message broker, if you will, for every message that goes through to open it up, look for a property B, if there is a property B, find out who's interested in property B, and then let them know. And every time you compose yet another message type, you have to go and change that custom content-based routing logic. It says, how do you open up and what do you look for in order to do routing? The reason there is no content-based routing in NServiceBus is because you don't need it. Just use interfaces to represent the semantics, and it'll all just work. That's actually one of the reasons why NServiceBus comes with its own XML serializer. Standard .NET serialization does not like to serialize interfaces. You give it an interface, say, here, serialize this. It says, no, I don't do that. Or similarly, I'd like to create an interface. How do you create an interface, right? How do you deserialize into an interface? Standard .NET serialization says, I wouldn't know how to deserialize an interface because I can't instantiate an interface. NServiceBus says, well, yeah, I know it's an interface, but you're telling me that it's a message. Because you're telling me that it's a message, that means that it's a data transfer object, which means it has no behavior, which means that I can auto-generate a proxy for this interface that has the exact same properties, fill it up with the information that I got from the XML byte stream, and give it to you, and that's okay. And the reason that that's okay is because it's a message. And messaging means something to the infrastructure. We don't let you serialize any old thing that you want. If you say it's a message, that has weight. And it allows the infrastructure to take a lot of assumptions about how it handles it. To do proxying, to do custom XML serialization, to allow you to do multiple inheritance. So it gives you a lot of those pieces that you didn't know that you needed until you actually try to version a system over and over and over again. And the code itself, I mean, it's not that difficult to write the code. When a message arrives, what do? Well, I handle this type of message. The way that you interact with NServiceBus, by and large, you're just implementing its interfaces saying, oh, my role is to handle messages of that type. So, NServiceBus, if you receive a message of that type, call me and invoke my handle method. And what do I do in here? Whatever your heart desires. Call a web service, write something to the database, use your domain model, use and hibernate. Well, do whatever you want to do. But you don't have to worry about this concept of, okay, how do I get in there? How do I register my handler? When you implement NServiceBus's interfaces, it'll register them for you. It says, oh, okay, I see what you want to do. You want to handle messages? I'll make sure when a message arrives, you get invoked. Next thing that you might want to do is say, well, what if I want more than one? Well, you might not actually say that because you've been so indoctrinated in the fact that you get a single web method and you have to put everything inside it. Some of the more adventurous of you may have tried to use AOP interceptors around your WCF service calls by plugging in Castle and whatnot. But the rest of you probably kind of said, well, okay, I get one method and I'll put everything in there. But hey, if you want to have more than one, no problem. Let me just go back a second so that it'll all compile. Oh no, I'm not using that part. So let's bring all this back to what it was before. And we can start adding. Let's add another message handler to one of them. Okay? So in version 5 of your system, you get a business requirement that says, when this message arrives, I want you to notify another web service. Behavior most people would do is go into the handle logic that you already have, come to the end of it, go, okay, call a web service. Unfortunately, now you've changed some code in the system. Now we got to recompile that. Now we got to redeploy that. Now we got to retest that. Because maybe you touched something, maybe you broke something else. It becomes a problem when you change the code that's already working. If all you want to do is an additive change, hey, don't change the code that you already have. Just write a new one. My new event handler, which handles messages of event message, and ReSharper fills that in for me. And in here, I'll call a web service. So let's say called the web service and got something. Breakpoint, run. And publisher publishes, and in message number 2, our new code gets called. Even if this code was in a separate DLL, and all you did was threw it into the runtime directory, it would have been picked up, registered automatically by NServiceBus, and invoked. So you don't need to add anything special. Don't need to change any of the code or the configuration that it took you months and months and months of production work to finally get it stabilized. And now, well, you're not scared because you wrote the code, but your manager is all paranoid and saying, don't touch anything. We finally got it right. Don't touch anything. I was like, can I add another DLL? Well, okay, but don't touch anything else. You can do that. Add another DLL, throw it in there, and have it picked up and run by NServiceBus. Now, there may be a scenario where you say, oh, but wait a minute. This needs to run before our existing code. It's easy if it runs after, but we have to run it before. That's the point in time often when you're dealing with not so much processing events, but processing commands. Somebody comes in version 12 of the system, says, well, it turns out that we wanted to do Kerberos authentication, but we can't do that anymore. I'd like to do X509 authentication this time. And you're beginning to think to yourself, oh crap, all the places that I'm going to have to change in order to do that. But what you can do is say, well, first of all, authentication, or that kind of thing that is generic, that doesn't necessarily have to handle a specific message type. I can say, well, for any kind of message, do your X509 authentication handler. And any kind of message that will go through this endpoint will invoke this code. So far, so good. We're now able to generically intercept every single message without changing any lines of code. That's a good first step. The next thing that we do is we need to configure it to run first, before all the other handlers. So one of the ways that we do that, we're in this subscriber number 1. So subscriber number 1, in case you weren't familiar with NServiceBus, NServiceBus has very small configuration. So this is enough to set up most of the configuration for NServiceBus. And if you're interested in the code comments, it'll tell you over here, hold on a second, indicates this endpoint as a server. As such, will be set up as a transactional endpoint using impersonation, not purging messages on startup. This configures about 5 different components inside NServiceBus. And I say, well, okay, that's nice, but now I want to do something special. I want to say that a message handler needs to run first without touching any of the other message handlers that are there, because I might break something. So you tell NServiceBus, hi there, I'd like to specify the message handler ordering. I'd like to tell you which order to run the message handlers in. Okay. And it gives you this order object. And you tell NServiceBus, order.specify. It says, which one would you like to have first? I say, well, I'd like to have my X509 handler first. And then I would like to have my event handler, event message handler. And NServiceBus says, super, off you go. So we're going to go to our event message handler, put a breakpoint over here, and we've got a breakpoint over here. And what we expect to see is that our X509 message handler runs first. F5. Right? We didn't change the original message handler. That's packaged up in a DLL. Oh, look at that. Because we stopped the subscriber the last time while it was in the middle of processing a message, the message wasn't lost. It rolled back to the queue. And NServiceBus says, well, you didn't finish processing it. Might have been very valuable information in there, like $1 million order. You wouldn't have wanted to lost a $1 million order just because a server crashed in the middle of processing. So here you go, it's waiting for you. Go do your thing. And you told me to call X509 first, so here he is. I say, okay, yes, X509 is done. And it says, oh, now event message handler. Without changing any of that code. Okay, that was good. However, one of the things that we know, like any pipeline, is sometimes authentication fails. Right? We don't necessarily want every single handler in the pipeline to run, especially if the X509 authentication failed. So, go back to NServiceBus and say, yeah, forgot. We need to say down here, we have some sort of if statement. So, go to Active Directory, do whatever it is that you do, have fun with X509, and when you're done, if that fails, and in this case we're going to say it fails, what we want to do is we want to tell the bus, stop right now. Don't call anybody else because authentication has failed. So to do that, we need a reference to a bus. So those of you familiar with dependency injection probably are familiar with setter injection. We'll say, okay, so declare a dependency on a bus. And you've got a bus. And in here, you tell NServiceBus if authentication has failed, bus, you can't miss this. Do not continue dispatching current message to handlers. In case you were wondering what it did, it tells the bus, once I'm done, to not continue dispatching the current message to anybody else in the pipeline. Because I said so. It's not an exception. We don't want the message to roll back. This message is done. So, we're going to put a breakpoint here. And this time when we run, this breakpoint up here should not be invoked. F5. We finished processing the last message, so we're going to have to send another one. So we're going to the publisher, sending a message. This is in subscriber number 2. How did a breakpoint get there? Fun with Visual Studio. So let's go back. It's not the one that we're talking about. Here, okay, we got this one over here. Make sure we don't have any other breakpoints. So we got that one over there. That's our X509 handler. And in the same one, in subscriber number 1, we have this breakpoint. No other breakpoint. So this time, in our publisher, sending a message, arriving at the X509 handler, which was configured to run first, F5, and that's it. In other words, we've intercepted the message pipeline. We've introduced some new logic in our version 13 of our software that now uses X509 authentication, without changing any of the other code. But in terms of the code that we actually did write, wasn't that difficult. Yes?
Can you also skip, for example, you've got a certain type of login authentication, and you change to a new type. You don't want to change any of the existing infrastructure, but you just want to not use the old type anymore. You just want to.
So just delete that DLL.
Okay, that's if it's in a separate DLL.
Why wouldn't you put it in a separate DLL?
Okay, so that's best practice.
Well, I mean, if you're looking for the ability to plug and play with your various handlers, make them physically plug and playable. If you intend them all to be there, then put them all together. But as a whole, I mean, there's really should be no dependency between one handler and another. Kind of the idea. So if you want to make it easy to swap out pieces of your app, make them into small little building blocks. And put this one in, throw that one out, put something else in. Okay, now run this one first, now run that one over there. And you get a great deal of flexibility in describing how your handlers should work. So it's not very common to have in a subscriber, when processing an event, some X509 authentication, or it's less common. It's more common when we're processing a command. So someone is telling us, create customer. Or saying, hold on a second, we're not willing to accept that message from just anybody. I want to check. So often this kind of authentication happens in the environment where we're talking about commands being processed rather than events. But if you want to, you can plug it in. It's fairly simple. So this is the handler pipeline, and as you can see, you can pretty much do whatever you want with it. Swap the order, intercept in the middle, and in there do whatever logic that you need. Any questions about the publish, subscribe kind of stuff, working with handlers? Yes?
Can you specify an order? Do you need to specify all handlers?
No, you only need to specify the handlers that you want to run first. So everything that you haven't specified runs after in any order. Okay? Yes?
Change the specifications if you have another one that you want to run first. And if you had the first rule before, would they change or?
So you're saying, so you've added another message handler, and then you want to change the order in which things run so that before this you have something else.
Yeah, but yeah, in a different handler.
So you'd say first, so first, something new, dot then, X509, and then, well, it doesn't have the something new. Well, let's create class something new. Implements, no, come on. Implements, I handle messages of iMessage. There you go. And no, the red is because it's asking for brackets over here. So you want something else to go first? Put it first and bump everybody else down. Okay? Or were you looking for something else?
You have another handler and you have already specified in the previous handler the first and then.
Then it'll run after them.
Yeah, then the first instance of the specification would run after the last one.
You only get one specification. In other words, if you say, that's why when you implement this interface, it is only called once. And you only get one place to do it. If you call it twice, then ultimately you override what you wrote before. Okay? So I don't want to say don't get too clever, but you should be able to handle most all scenarios with respect to pipeline ordering with this. In the case where this isn't working out for you, it's quite likely that you're trying to build some kind of orchestration broker thing that all the messages in your system are going through one centralized endpoint, and you have a bunch of different rules that you'd like to configure in some sort of nice workflow foundation, if-then-else activities thing. Use workflow for that. That's not what this is for. Okay, this is a specific endpoint focused on a specific type of message saying, what would you like to do in that order? Okay? And by and large, you'll be having all your validation steps happening before any of your doing something steps. So just a second. Yep.
What is the messages going across? I mean, as per protocol, or how does it communicate across servers?
So between machines, it's using MSMQ by default. If you want to swap out MSMQ with some other queuing technology, there's an interface called iTransport. Write that, put it inside the container, and NServiceBus will use that. Now, some people might say, but I don't have queue-based communication between all of my machines. I may have a multi-site deployment, where on this LAN I may be able to use MSMQ, and on that LAN I might be able to use MSMQ, but I may not be able to use MSMQ between them. Is that kind of the scenario that you're talking about? Okay. So multi-site scenarios break down into two scenarios. Okay? Number one, disaster recovery. Okay? Where to a large extent what we're talking about saying, this site is really a backup of what's going on over there, and it doesn't have a specific business significance. Okay? And often the failover from one site to another is a manual step. Right? There was a disaster, somebody presses the big red button, and it takes 5, 10, 20 minutes, an hour, until everything gets migrated to the new site, all the connections have been, everything's okay. We may have lost the last 10 minutes of data because the SQL Server log shipping does not run every second, we do it every 10 minutes or so, and now everything's running on the backup site. In those kinds of cases, you are not using NServiceBus for communication, because it's a disaster recovery kind of scenario where SQL Server log shipping, your standard replication technologies, are taking things from one site to the technical replica of the site. So that case, don't worry about it. The other case where we're dealing with multi-site is where the sites have business significance. So let's take, for example, a bank or a grocery chain or something that we have multiple physical things, but it's not, well, it could be described technically in terms of, well, it's an active deployment. It's not really, right? One branch of a bank is not an active backup of another branch. It's not defined that way in technical terms. So when we have a multi-branch setup, what we often also have is, beyond just all of these branches at this level, we usually have some sort of HQ, some central place that says, we're the boss. All these guys are branches. Sorry, that's 3, bank number 4. But we decide what the interest rate of the bank is. In other words, these physical sites, while they're interesting from a network level, from a protocol level, from a communication level, there is also a business semantic around the reason for existing. And we need to be aware that that exists and to look for it. So in the case where we have, say, the concept of interest, there's a place where we say, okay, what will be the interest for our bank on mortgages? So we have a mortgage service that is saying, I've decided that until the end of the year, the mortgage rate, or the insurance that will be paid, the interest rate that will be charged on mortgages of this type will be 3%. So anytime any of you are doing something dealing with mortgages, you need to know what the interest rate is. But the thing is that if we look at that that mortgage bubble. Mortgage, M-R-G-T. We have a mortgage HQ, and we have mortgage capabilities at every single branch. In other words, it's not a technical decision. People can apply for mortgages at any bank, and at any branch. And even if these guys aren't connected to the main site, somebody should still be able to apply for a mortgage. That's just life. So, the second scenario, which is this one, the more interesting one of the multi-branch sites within HQ, is significant because it means, well, not all sites are created equal. One of them is the headquarters. And the other thing that it tells us is that we're not looking at synchronization between sites. We're not doing this sort of disaster recovery scenario. So while it is technically appearing as if it's active, the semantics of, but this is a branch that means something in the domain of the bank. And so all the mortgages that are sold over here are tagged by that branch. The branch manager said, hey, if you have been able to get more mortgages, this quarter, you get a bonus. There's some logic in this area that says, not all branches are identical. Not talking about a shared database. So when talking about communication and service buses and whatnot, what we tend to see is that the communication that goes between sites is within the same logical service. So this is the green talking to the green that happens to be somewhere else. However, what tends to happen is when I'm talking about green talking to purple. So the mortgage application that needs a life insurance quote, often I have the same life insurance forms here, and I have life insurance here, and I have life insurance up here. So in most branch setups that we're dealing with, we have every logical service at every physical site, because each site is able to operate independently. So what tends to happen is these guys talk to each other within their site, and these guys talk to each other within their site doing publish subscribe. But when we're talking about inter-site communication, we're almost always, and when I say almost always, it's because I'm an engineer. I don't like to say always because 100% doesn't exist. But if you think that you have a situation where you're in an almost scenario, go check your business a little bit, where the propagation of information from one site to another is done within a single service, where we're often talking about a master-child relationship. I am the one that gets to state what interest rates there are on mortgages within the domain of mortgage. However, within your site, so when talking to life insurance in your branch, when talking to credit balance in your branch, when talking to this, that, and other thing in your branch, you're the local earl, the duke. You're the duke of mortgages in your site. So anybody that sits around you, they need to talk about mortgages, they talk to you. You're the boss here. However, within the grander scheme of things, you're just a duke, and the king is up here. Not just any peon in your fiefdom is going to get an audience with the king. Doesn't work that way. So they talk to you, and if you feel that you can't handle this yourself, all right, then maybe you and me, the duke, can request an audience with the king. But inter-site communication is that within service kind of integration. So we'll be doing some MSMQ, PubSub, and service bus communication here, but often the data propagation that needs to happen at this level is often in the form of, at the end of business today, I send a letter to my king saying, "Oh king, my king, these are the mortgages that I have sold on your behalf today." And there is no response. This information propagates all the way up here. I may be using a nightly batch FTP, I may be using carrier pigeons to send my letter to the king, whatever it is. However, that kind of communication between sites is a very specific inside a service communication. And as a result of it being inside a service, that's often the place where we start to use the more integration-centric technologies. We say, hey, you know what, let's do a web service call. That's okay. Or maybe we have the ability to set up a VPN between these sites, where we've got an MSMQ VPN that connects both sides and says, but we don't want to flood this VPN because we have very low bandwidth. So we don't want any and all communication to be able to just go out over the VPN, which is why we say it's in the context of a service, in a single locus of control, where we say, over here now I choose to do something, I'm very conscious about when I talk to my king. I'm not going to waste his time over just anything. And once the information gets propagated over here, once again we may switch over from a web service to NServiceBus-based communication. Or we go from the VPN back to the LAN. So most scenarios, you're dealing with multi-sites that have business meaning. You're talking about branches where one of the physical site is a headquarters. Look at having a representation of each service at each place, where most of the publish subscribe, most of the communication based on NServiceBus will be local to a single site. And occasionally you'll be doing those data dumps, notifying them, saying, these are the mortgages that I've sold today. And the king will be notifying a subject saying, the interest rates for mortgages from this point on will be this. And pushing that information out over all of these channels. But this communication tends to be quite limited. Most of your communication happens within each of these sites. Does that answer your question, John? Somebody else had a question. Yes?
If you want to notify me when one of my customers purchases some kind of insurance from his company, would that be by that notification? Would that be by NServiceBus or served by VCF or some web service call?
So the answer to that...
I just want to know when something changes. If someone buys something new, or if they change some of their existing appointments or agreements.
Well, part of that has to be, are we in the same logical scope? So the fact that, he's, one system and you're another system and I'm a third system, there may be a situation where we say, yeah, but going back to this picture over here, say that we have, a system over here, Amdocs. We also have the same system up there, Amdocs. Or, this is a web service by a third party, and we are using the same web service in another place. Context matters a lot. In other words, the same party, the same application may be integrated in multiple business domains. So the question that you're asking that says, when one app says this and another app says that, how should I communicate that out? I said, well, if both of these apps are within the same business domain, this is billing, that's billing, and I'm also billing, then I'd say, hey, yeah, WCF is a fairly good choice for this kind of or inside a given business domain integration. Because we're all talking about the same kind of information, and we want to make sure that UI and everybody else are all in sync. We want to be tightly in sync before we publish an event to anybody else saying, we've got a new customer. Because if we didn't, right, if I talked to him and I said, well, I don't know about you, And I'll publish, there's a new customer. And a subscriber over says, oh, a new customer, great. Mutz, have you heard about this new customer? I want to give him a discount. We're like, what customer? Go away. It wouldn't work. In other words, we have to make sure that when we publish something, when we expose something from our domain, that we won't get into trouble when someone asks an app about it. So the question that you asked said, say customer information has been updated and you want to know about it. The question is, do you also have customer information? You know, you have one set of customers, he has another set of customers, I have a third set of customers, and all of us together are playing in the CRM service, that only after all information is in all three apps do we dare tell anybody else about this? Or is this a scenario where you say, no, you're sales. All you want to know is there another customer because I want to accept orders from them? In which case I'd say, oh, no, you don't. You're out there in sales. Me and John, we're going to keep each other in sync in a fairly tightly coupled way. And only after both of us are sure that the customer exists in both of our databases will we publish out an event to the world saying we've got a new customer. In which case, you could maybe finding out about that via an event in NServiceBus, which may be integrated back via BizTalk into your Salesforce app. So it really matters what your responsibility is. Which color are you? Are you on our team? We're the greens. No, you're purple. No, you got to listen to an event. So there is no immediate answer for inter-application integration. First, we have to decide, where do you sit in the grander scheme of things? And then we'll be able to answer that question. Now, in this kind of multi-branch scenario, it could be that we have a back-end system that only exists up here. Right? It's quite likely. However, it's much less likely that we have a back-end system that only exists down here. In a multi-branch kind of scenario, each branch does not get to decide on its own what its IT infrastructure is going to look like. So, oh, okay, I'm going to have this, that, and the other thing, and I'm not going to talk to my HQ about it, and then they're going to have their own back-end kind of apps, and he has his kind of apps. We're going to have a mess trying to decide, who's responsible for what. Ultimately, we have to make a decision, say, who's king? And the answer said, HQ is king. Said, but I've got an app down here. The HQ says, no, you don't. We're taking it, and the box that it sits on, and we're putting it over here. If you like, we'll send you a feed with the data that we've managed up here. But not just anything sits anywhere. There's a reason for it. And ultimately, we need to find out those business reasons and represent them in sort of this level of topology so that we can say, oh, okay. So we've got the back-end app integrating within this service over here. Then we're going to use SQL Server replication to bring it down to all these places. Once it's down here, it'll be stored in a local database. So you really need to have these boundaries down when you're dealing with it. Okay? So I think there was another question from before. Did you have a question?
Your example of where you put in a new handler.
Yes.
You had one endpoint config. Is that for each DLL or for each EXE?
For each EXE, you have an endpoint config.
What I was wondering, if you put in a new DLL, then you have a mandate, like you said, that doesn't want you to change anything. But you need to put in a new DLL where you have specified a second order, another order.
Mm-hmm.
Is that possible?
It's not another order. It's saying you want to change the order.
Yeah, if you want to change it. Yeah.
So that's the point in time where eventually you have to come to your manager saying, if you just wanted it on the end, I can do that. In order to put it first, I need to tell the endpoint that it goes first. So ultimately, I do need to change something. I said, okay, but only touch that. Right? Touch the minimum amount of code, and don't touch anything else. I don't want you touching any pre-existing handlers until those things work fine. So you kind of show this code to your manager and say, this is the only line of code that I've added. Right? You told me first run something new, then run X509 authentication. This is all that I've changed. Here, source control is proving me right. So this is the only thing I've changed besides adding that handler. I don't think I could have written any less in order to get this done. Now, some people might say, yes, but if you put that in an XML configuration file, then you wouldn't have needed to touch code. That's the case where NServiceBus takes a fairly clear stance and it says, but you wouldn't want an administrator accidentally swapping the entries of that XML config. There are some things that a developer needs to specify that an administrator shouldn't be able to change. Definitely not accidentally. So those things which are developer specified, like the order of handlers. The order of handlers has a significance to the correct runtime behavior, as we've seen. We wouldn't want an administrator, when fiddling with configuration files, as they tend to do, to swap that around. So that's one of the things that NServiceBus takes a fairly strong stance on. It says, if you as a developer should be specifying this, I'm going to have you specify that in code. In about the minimal amount of code possible, but in code, so that an administrator won't fiddle with it. And vice versa. If this is something that an administrator should configure, and not a developer, then I'm going to put it in the configuration file, and let's take a quick look at an NServiceBus configuration file. For example, where is my input queue? Or what error queue should I use? Where does that publisher sit? This kind of information is the kind of thing that developers probably should stay away from. Developers shouldn't specify where things sit. Now, some developers want to anyway. NServiceBus will make it very hard for them to do that. I get all sorts of questions in email. How do I specify the input queue in code? You can, but you'll have to work for it. Because you really shouldn't be specifying it in code. Now, some people say, yes, but I don't want to use an app config. I want to store my configuration in a database. That's the point in time where NServiceBus said, oh, that's something different. You don't actually want to control this information via code. What you'd like to do is to specify a different configuration source. Why didn't you say so? If you wanted to specify a different configuration source, the way that you do that is by telling NServiceBus in the form of, I want custom initialization. And you'll tell NServiceBus, configure with custom configuration source. And then you'll pass in your object that implements the iConfiguration source, which will pull the data from a database. What you're doing is you're telling NServiceBus how to get the configuration in code, but not what the configuration is. And you want to put it in a database? Fine. Then have the administrator play with the database. But I'm still going to make it hard for you to latch your grubby little fingers on input queues. Don't touch those. It's not for you. Just like administrators, I say, no, I'm not going to let you break the order that the developer specified. No, that's not for you. Everybody gets their own piece of the pie. You play in your sandbox, you play in your sandbox, anybody that has kids. You go to your room, and I don't want you talking to each other until you agree to play nice. Right? Don't steal the other kids' toys. That's what NServiceBus is doing between developers and administrators. And If you think you want to do it, there's probably some kind of API that you just haven't found in NServiceBus that will achieve what you're trying to achieve, but maybe in a different way than what you intended. So custom configurations are something that people tend to ask for a lot in the form of, I want to specify the input queue. What else have we got here? Well, we got a little bit over time. So I don't want to, this isn't an NServiceBus course because then it would be a very long period of time, or to teach you every single NServiceBus API because there are a lot of them. But to give you a feel for what it's for, what the metaphor of NServiceBus is, what actually a service bus is, and more importantly, what it is not, and to show you that when you're working according to the guidelines of the tool, so given that I have only a single publisher, then it's fairly clear why I should have, for a given message, only a single publisher entry in here. If you try to tell NServiceBus, no, NServiceBus, I actually want to have two. So, and this happens a lot. People start out saying, okay, after I've done all this, now I want to have the same messages published by two publishers. Right? I have two machines that can publish the same message. I would like to subscribe to them both. And you'll run NServiceBus, and NServiceBus will tell you, no, bad developer. No cake for you. And eventually it'll tell you, the entry my messages has already been added. You don't get another one. You only get one. But I have two boxes which are publishing the same thing. Oh, you want to scale out your publisher, right? You want to have, as we showed in this picture here, multiple boxes that are green. Hey, no problem, we can do that. What you need to do is to have the list of subscribers shared between all of your green entries. So all you need to do is to tell NServiceBus, here's a database where I'm going to be storing my subscribers. This happens automatically when you move NServiceBus into production, by the way. So one of the things that will be happening here, so let's return this to what it was before. If you want to scale out a publisher, one of the things that you need to do is to tell it, as you would do in production, NServiceBus run in production. And NServiceBus at that point in time says, oh, we're going to production. I'm going to go scale out now. And when you go to run your publisher, it'll tell you, but if you want to run me in production, there it is, unfortunately because I don't have the PDBs here. Exception when starting the endpoint. Reason, no configuration section for your DB subscription storage. Please add a DB subscription storage config section to your configuration file. What you're doing is you're saying, all of my green guys need to have a shared database where they put their subscribers. So it doesn't matter which one you talk to. They're all the same. So talk to one. And usually that one will be the green guy's distributor. Because you shouldn't know how many machines are out there. So green will give you, just like you do with your websites, you're going to be creating a CNAME entry in your DNS saying, telling the world, if you want to talk to me, here's my load balancer. Send messages to this load balancer. And then that load balancer will distribute the messages between all these green guys, and all of them are looking at the exact same database. So you'll be telling your subscribers, say, hey, talk to in their app config, this is the distributor. Go ask him. If you want to subscribe, go tell him. He'll figure out who to forward it to, and they'll put that information in the shared database. But there should still be one logical identifier, one green thing that everybody uses their name. So in all those cases where you think you need to have more than one, what you're ultimately doing is trying to scale out. NServiceBus, as a service bus, is aware of the concept of scaling out. Let it guide you. Say, okay, you need a database for this, and you put a distributor over there. Tell all your subscribers to talk to that load balancer. And then you need to connect all of your publishers to the same distributor. And the way that you do that is you give it the 2 queues. So each distributor has 2 queues. So tell the green box where its load balancer is, and you'll be done. Give it a database for subscription storages, give it a distributor, and that's it. From that point on, tell everybody else, my address is this load balancer. You talk to the load balancer, it'll get where it needs to go. Every color gets its own load balancer. Every color gets its own distributor. Every color gets its own DB subscription storage. All the scale out, let the service bus guide you in the way that it needs to work. Don't try to force it. What you do need to get right is, when dealing with multi-site scenarios, what are the business semantics of the various sites? They're there. Or if it's a purely disaster recovery scenario, don't use NServiceBus for that. SQL Server, log shipping, all that kind of disaster recovery stuff, handled by infrastructure. The next thing that you need to focus on when designing an NServiceBus-based solution is your events, the semantic meaning of those events, figuring out who is the one and only one logical entry, logical thing in the world that gets to state this. Keeping in mind that if you publish 2 events one after the other, doesn't necessarily mean that everybody gets them in that order. So keep in mind that from and to information often has a business semantic, right? Until what time is this price valid to? The price of bananas next week will be X. And the price 2 weeks from now, bananas will go on sale. Most things don't have a single instantaneous value, even though Northwind tells you so. Don't believe Northwind. It's just a terrible liar. Take the time, map out this business logic stuff. When you're able to get down your business logic to that single concept of a publisher, and each event has a single publisher, but a publisher can publish multiple types of events. When you're able to follow that kind of guideline, using NServiceBus will be more and more straightforward. When using NServiceBus, you should have to write fairly little quantities of code, like we saw before. Right? You want to specify ordering, it should be fairly easy for you to do. If you find yourself working hard, writing lots of NServiceBus specific code, you're probably doing it wrong. Stop. Go back to your drawing board, try to figure out if maybe you can rejig the responsibilities. And if you get into trouble, hey, there's the discussion group, and I'm not sure if the NServiceBus site has come back online, but let's cross our fingers. If it hasn't, you'll see a link right here on the top to the discussion group, where there are a bunch of people just like you at various skill levels within NServiceBus that have probably made some or all of the mistakes that you're currently making. You can ask a question, and you usually get the answer in under an hour or two. because there are enough people all over the globe. No matter when you ask, somebody's awake. And really, don't try to fight the tool. It's been around long enough and seen use in enough business domains that these rules of using service buses really do work out. It takes some time, it takes some adjustment of thinking. And if you find yourself falling back to the synchronous RPC thinking, stop a second and say, what would this be like if it were Ethernet? From something that you understand. Because that metaphor is actually very good, or is very translatable to the way that service buses work. Okay? So, we'll take 10 more minutes for questions, if there are any, and then we'll wrap it up and go for geek beer. That's my way of telling you don't ask any more questions. Thank you very much.